Hello. The theorem of Pythagoras can be proved in several ways. I'm going to show just one of these proofs. It states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Algebraically, a squared plus b squared is equal to c squared, where a and b are the smaller sides of the right-angled triangle and c is the hypotenuse. So I am going to start with a right-angled triangle whose sides are a, b, and c. So there is a 90 degrees here. This shorter side is a, this is b. C is my hypotenuse. So what I'm going to do is, I'm going to redraw another triangle identical to that. Or I'm going to take the same triangle, rotate it through 90 degrees, it becomes in this position, then I shift it downwards like that. So this triangle is exactly the same as this one. So let me suppose that this is alpha. The angle opposite side A is alpha, and the angle opposite side B is beta. Okay? What it means is that alpha plus beta should be equal to 90 degrees. Why is that so? It's because this is 90 degrees. If this is 90, it means these two shall add up to 90, so that altogether in a triangle, the interior angles add up to 180 degrees. So alpha plus beta is equal to 90. Let's keep that in mind. If this is the same triangle as that one, it means this is still C. This side here is still C, the hypotenuse. Okay, right. So this is a continuous line. This angle shall be beta. This one shall be alpha. Okay, right. If alpha plus beta is equal to 90 degrees, that is, in this triangle, alpha plus beta is 90. That means on this straight line, if this is alpha and this is beta, we know that alpha plus beta is 90. So these two give me 90, which means this one must also be 90, so that the 90 that I get from the sum of alpha and beta needs another 90, so that the straight angle will be 180 degrees. Okay, the next construction that I'm going to make is join this corner to this corner to form a straight line. So I'm going to extend like that. Okay, fine. We are going to use area, the concept of area, to prove this theorem. So let us focus on this triangle here. We are going to use the formula area of a triangle is half base multiplied by height. So area of triangle, this triangle here, will be half base times height. If I let my base be A, then my height shall be B. Okay. Then also, area of this triangle should be half base, which is half of B multiplied by A. If I simplify this, this will simply be half AB. This is half AB as well. Okay. What about the area of this other triangle that has been formed by joining like this? Your base is going to be C, your height is C. So the area of that triangle should be half of base multiplied by height, which is half of C squared. Now, I am going to add the areas of all the three triangles, this one, and this one. So if I combine this one and this one, I'm going to have half AB plus half of AB. Half of a quantity plus half of a quantity. Half AB plus half AB should be AB plus half C squared. This is the sum of the three triangles. Area of three triangles is equal to this one. So it's the whole shape that is closed there. But now, I am aware that if this line and this line are horizontal, because this is 90, this is 90. This is horizontal, this is horizontal. What it means is this line and that one are parallel, so I can show that they are parallel by putting arrows that go in the same direction. If this and that are parallel, then this quadrilateral here is a trapezium. And I have got a way of getting the area of a trapezium. The formula for area of a trapezium is half of the sum of the parallel sides multiplied by the perpendicular height. In this case, the parallel sides are A and B. Okay, so I'm going to say area of trapezium is equal to half of, which two sides are parallel? It's A and B, so it's A plus B multiplied by height. The height is the perpendicular distance between these two parallel sides. So this is my height of the trapezium, which is also A plus B. This is equal to half, I'm going to keep it outside. Expanding this, I'm going to have A squared plus 2AB plus B squared. Fine. Then we are going to remove the brackets. If we remove the brackets, we will get half A squared plus half of 2AB will just be AB plus half of B squared. Okay, so you agree with me that the three triangles added will give me the whole trapezium. So area of the three triangles must be equal to the area of the whole trapezium. That's what I'm going to do now. So I am going to take the area of the whole trapezium, which is half of A squared plus AB plus half of B squared is equal to that sum that we found of the three triangles, which is AB plus half C squared. Okay. Now, AB and AB are the same. If I take this one that side, they will simplify to 0, because AB minus AB will give us 0. Therefore, what survives is half A squared plus half B squared is equal to half C squared. Multiplying both sides by 2 to clear the fractions. If I multiply this by 2, by 2, by 2, I get A squared plus B squared is equal to C squared, which is the theorem of Pythagoras. So I've arrived here. This is how you can use the concept of area to prove the theorem of Pythagoras. What this shows is topics in mathematics, concepts are interrelated. We can use that concept to derive that and so forth. That is it as far as one of the proofs of Pythagoras is concerned. Thank you very much.